Okay, today we're going to talk about factoring special products, and I'm going to start off with part one, which is factoring dots. Okay, and remember that dots represent the difference of two squares. For example, you might see something like x minus 7 times x plus 7. Okay, so if you were to FOIL this, you would get a special product called the dot. And let's see how that happens. If you remember, multiplying the first terms, you get x squared. The outer terms, you get a negative 7x. The inner terms, you get a positive 7x. And the last terms, a negative 49. Okay. Notice that the inner terms and the outer terms are additive inverses, which means they will cancel out. Okay. Your product will be a difference of two squares. Difference meaning it's a subtraction, and two squares. The first term is a perfect square, and the last term is a perfect square. So we recognize these as special products called dots. When we factor dots, what we're doing is we're going backwards. To factor, you're going back to the two binomials that make up the dot. Okay? So to undo dots, let's write down the steps. The first thing is you must recognize a dot as a dot. Okay? And the second thing you need to do is to break it down. Okay? If f squared is a perfect square, you're going to find out what the square root of that is. Find out what the square root of the last term. And then you can rewrite them as two separate binomials. Notice that one sign's a positive, one sign's a negative. That will give you the opposite signs in the inside and outside, which will cancel out. Okay? So let's start off with an example. Let's write this down. When you're doing this problem, what you're first checking for is to make sure that this is a dot. So 4x squared, is that a perfect square? It sure is. You know that 4x squared is, if you take the square root of it, 2x squared. Okay? And 81 is also a perfect square. That is 9 squared. Okay? So here you have your first and your last. So now we can rewrite it as two separate binomials, one being a plus and one being a minus. Put your first term in the first and your last term in the last spot. Okay, and the neat thing about factoring is that you can make sure that you have the right answer by multiplying and checking. Okay, you can do a double check. So first terms, 4x squared. Okay, outer terms, negative 18x, inner terms, positive 18x, and the last terms, negative 81. Again, you have the positive and negative additive inverses, and what you have left is what you started off with. So this means that it checks, which means that you have completely factored your dot. This will be your answer. Okay. So the trick though is being able to spot the dot. Okay, I want you to write down examples A, B, and see if you would classify these as either dot or not a dot. Okay, let's start off with this first example A. Okay, did you get that this is indeed a dot? Yes, it is. Yes, it is. Okay, and it may not look like it at first glance, but we can use the commutative property here to change the orders of the terms. I'm going to put the positive 4 first, and then move the negative 64x squared last. Okay, what you see here is that it is a difference, and positive 4 is a perfect square. 64x squared is a perfect square. Okay, And this would be 2 squared minus 8x squared, so that we know if we were to break it out, we can factor it to 2 plus 8x and 2 minus 8x. Okay, this would be your factored, completely factored dot. Okay, what about b? Okay, b is not a dot, not a dot. And why is that? Well, you may have noticed that there's a 12 there, or 12a to be exact. And 12a is not a perfect square. Okay? And what else do you notice about this? Can we factor out any GCFs? No, they do not have anything in common. Okay? So if this is a binomial, it's not a dot, and you can't factor out GCF, that means that it cannot be factored anymore, which is what we call prime. We would label it prime. Okay. C, let's take a look at this. What do we notice here? Well, first off, I notice that these are two even numbers. So I'm not sure if it's a dot yet, but I definitely know that I can factor out a GCF. And let's figure out what that GCF is first. Okay, and if you recall, we can use the ladder approach. Okay, I know that they're both even numbers, so let me factor out a 2 first. Factoring out a 2, I'll have 16x to the 4th, and half of 512, that's a negative 256. Okay, wonder if anyone has recognized this number yet. Okay, this is in our perfect squares list. You know that 16 goes into 16 once, so I'll have x to the 4th left, and 16 goes into 256 16 times. Okay, so what we have here, we don't have any more common terms, but we started off with this binomial, and we factored out terms. We factored out a 2, we factored out a 16. So our GCF is 32. Okay, so what this becomes is 32 times our remainder. This is our remainder. Here's our GCF. Okay, x to the 4th minus 16. Okay, so this is what we have after we factor out the GCF. However, are we done yet? You may have noticed that x to the 4th minus 16 is indeed itself a dot. It's a dots, okay? So what we have is a dot within a dot, a double dot, so to speak. I know that I can have x squared squared to get x to the 4th, and I know that 4 squared gives me 16, so that means that I can break this out to x squared plus 4 and x squared minus 4. And remember to bring down to 32. Okay, so far we've factored this problem into 32 times x squared plus 4 times x squared minus 4. But, oh my goodness, take a look at this. We have another dot, don't we? Which means I can again factor this out. Okay, this is x squared, and this is 2 squared. Okay, so what I have here is 32 times x squared plus 4 times, and this is x plus 2 and x minus 2. Now we have completely factored this binomial. Okay, and let's do a quick check. This is a plus sign, so that can't be a dot. It doesn't have any more common factors. This is a plus sign, it's not a dot, doesn't have any common factors. Minus sign, but that's not a perfect square, and 2 is not a perfect square, doesn't have any factors, so that means that this is completely factored. Okay, what I'd like for you to do is let's write down the steps that we use to factor the dots. first thing, we always make sure that we factor out the GCF if we can. Okay, always start with factoring out the GCF. Then, if you spot a dot, you have to factor the dot. Okay, once you factor the dot, you got to check again. Are there dots within a dot or double dots? Or are there even triple dots like we saw in that last example? Okay, please take care of these two problems and bring them to class tomorrow. You also need to watch part 2 of the video, which covers factoring PSTs. Okay, in the second part of special products, we are factoring the perfect square trinomial. Okay, so PST does indeed stand for perfect square trinomial. If you recall, it looks something like this. Okay, so this is x plus 5, the quantity x plus 5 squared, which really means x plus 5 times x plus 5. Okay, do you remember the shortcut for this? Okay, the shortcut for this, if you recall, was first squared, last squared. In the middle, remember, we're smiling to get 2 times the first times the last. Okay, so if you don't remember, you can still FOIL this out and still get an answer. You still have first x squared plus 5x plus 5x plus 25. Okay, the signs are the same, which means the inside terms are doubled. Okay, so x squared plus 10x plus 25. Okay, and let's see if we had used a shortcut, if we had come up with the same answer. The first squared, x squared, the last squared, 25, yep, and 2 times the first times the last. If we're smiling here, we get 5x, we double it, we get 10x. Okay, so this is a perfect square trinomial. So know that what we're going to do today is we're going to start with a perfect square trinomial, or PST, and we're going to go backwards to its factored form. Okay, so let's first start off with the steps. To undo a PST, the first thing you need to do is to, 1, make sure it is a PST. Okay, so you want to check, is the first term a perfect square? Is the second or the last term a perfect square? And you check the middle, is that the first times the last doubled? Okay, once you do that, and you're taking a look at the form, what's really important is just to take a look at that sign, that first sign, because that first sign is going to tell you what form, what sign to have in your factored form. Okay, so keep in mind that the last sign is always going to be a plus. Okay, and start thinking about why that's the case. Okay, you cannot take the square root of a negative. Okay, and you won't do that until you get to high school and you discover imaginary numbers. But for now, in Algebra 1, we always tell you that this cannot be a negative. Okay, so these two cannot be negative. Just keep that in mind. Okay, so really what you're only looking for is make sure it's a positive, and then your first sign will tell you the sign in your factored form. Okay, so let's start off with an example. Okay, and I'll keep the instructions up here, so we'll start off making sure that this is a PST. Okay, well, let's check our first term. First term is a 9x squared, and that is a perfect square. That's 3x squared. Okay, and let's check our last term. It's a positive 16. Remember, it has to be a positive. Square root of positive 16 is going to be 4. So 4 squared will give us 16. Okay, so far so good. Let's multiply this together. 3x times 4, you get 12x. You double 12, you get 24. So that checks as well. Okay, so first off, yes, this is a PST. So now we can factor it. And let's review the forms again. Okay, this does have a minus sign, so I know that I'm going to have first minus last squared. So my first is 3x, my last is 4, and it will be minus. So I'm going to write this out neat. 3x minus 4 quantity squared. Okay, as always, we can check our work. Okay, 3x minus 4 times 3x minus 4. And first terms, 9x squared. Outer terms, minus 12x. Inner terms, negative 12x. And will be positive 16. Again, these will be doubled. Okay, so negative 24x plus 16, and let's see. Take a look. We end up where we started. So indeed, this is the factored form of the P.S.T. Okay, let's see if you can spot the P.S.Ts. Please write down these 3 examples, and right next to it, write a yes for a P.S.T. or no P.S.T. Okay, let's talk about this first example in A. Again, we want to check the first term. Is this a perfect square? Well, I know that 4x squared will give us 16x squared. So yes, that is a perfect square. What about positive 64? Well, yeah, that's 8 squared. But let's see. If I take 4x and I multiply by 8, I get 32x, and then I have to double it. I have to multiply that by 2. I'm supposed to have 64x, but look here, it does not match up. Okay, so this is not a P.S.T. Not a P.S.T. Okay, so it can still be factored because these are all even numbers, but we just want to make sure that you can spot the P.S.T. for now. So let's just say not a P.S.T. But remember to factor out a GCF. Okay, let's look at B. First term, 3y squared, that's okay. Last term, 2 squared. All right, so far so good. 3y times 2, so 3y times 2 will give us 6y. Double that, we would have 12. Yeah, so this is a P.S.T. Okay, so if it is a P.S.T., let's take a look at what our form will be. It's minus sign, so I know I'll have some first minus last squared, quantity squared, and I'm going to put the first term there and the last term there. Okay, so here's my completely factored form. Okay, and the very last one. Let's take a look at C. Okay, n squared, well, yeah, that's n squared. Negative 144. This is where I said to be very careful. You cannot have a negative here because, yes, 144 is a perfect square, but how can we make a negative? By squaring. If I squared a positive 12, I'd have a positive 144. If I squared a negative 12, I'd still have a positive 144. There's no way we cannot make a negative if you're going to square it. So this is not a P.S.T. Not a P.S.T. Okay, so good job with that. Feel free to do problems number 4 and 6 on page 458 and bring that to class tomorrow. And we'll talk about both sets. So that's the set from factoring dots and also from this section here.